Welcome back. Problem 6.9. The statement is express the internal shear and moment in term of x and then draw the shear and moment diagram for overhanging beam. So you can see the beam, overhanging beam, the load, uniformly distributed load is 6 kilonewton per meter, and at point A there is support as well as a roller support at point B. The total length of the beam is 6 meter. So first of all we will find the unknown reaction forces at point A and at point B. So let this is AY and at point B this is BY. Clear? So I will draw the free body diagram over here. So let we have this beam. Clear? And at point A we have this load AY. Clear? And at point B, let this is point B, so we have load BY. This is point B, this is point A. The distance between point A and B is 4 meter, so this is your 4 meter distance, and from B to A till the end this distance is 2 meter. Now above the beam there is 6 kilonewton per meter distributed load, so you have to convert this distributed load into concentrated load. So we will convert, how we will convert, we will 6 kilonewton per meter into total length of the beam is 6. So this will be 6 and it will be into kilonewton, and this force will act at the middle of the beam. So let this is the middle of the beam. For example, this is the middle of the beam, so this load will act at the middle. So at middle means that total length is 6 meter, so it will be equal to 3 meter, and this remaining, since this is 4, so this remaining is 1 meter. Now we will find the unknown reaction forces AY and BY. So we will apply the equilibrium condition that sum of all movement about point A is equal to 0 and taking the counterclockwise movement as positive. So due to this load and this BY, it will produce movement about point A. So first is BY, so BY into perpendicular distance is 4, so it is producing counterclockwise movement, so it will be positive. The second force which is producing movement is this 36 kilonewton. So minus 36 into perpendicular distance is 3. Clear? And this is producing clockwise movement, this force, clockwise movement, so this will be minus. Their sum must be equal to 0. So when you solve this, you will get BY is equal to 27 kilonewton. So this is your first reaction force BY. Now we apply the second equilibrium condition that sum of all movement about point B is equal to 0 and taking the counterclockwise movement as positive. So at point B, two forces is producing movement. One is this one and the second is AY. So we'll start from AY. So AY into perpendicular distance is 4. Clear? So AY into perpendicular distance is 4. The AY into perpendicular distance is 4. Plus this is producing clockwise, so it will be minus. The second force which is minus, which is 36 into perpendicular distance is 1, and this is producing counterclockwise, so it will be positive. Their sum must be equal to 0. So it means that 4AY is equal to 36 and AY is equal to 9 kilonewton. Now we have this reaction force AY is 9 kilonewton and BY is equal to 27 kilonewton. We will move toward the other part, draw the shear and moment diagram for overhanging beam. So shear and moment diagram. So for that shear and moment diagram, we need shear and moment functions at various length of the beam. Clear? So first we will cut the beam from x is greater than or equal to 0 and less or equal to 4 meter. So means you can cut the beam anywhere and you have to draw the free body diagram. So let this is This is point A where we have 9 kilonewton. Clear, total length is x. We do not know because x is greater or equal to 0 and less or equal to 4. So whenever you cut the beam, there will be a shear force V and there will be external moment M. Clear. Now there is a distributed load acting over the length of x. So we will convert this 6 into distance is x. Clear. And it will be acting at the mid. So this load will be equal to 6x kilonewton. This will be in kilonewton. It will be acting at the mid of this beam. So this is x, so it will be x by 2. Let this point is point J. So we will find this shear force and bending moment. First, we will find the shear force. So sum of all forces along y direction must be equal to 0 and taking the upward force is positive. So there are 3 forces. One is this, second is this V, and third one is this. So 9 is upward, which is positive, minus 6x, which is downward, minus V is equal to 0. So from here you will get the shear force is equal to 9 minus 6x and the unit will be kilonewton. So this is your equation number 1. We will find the moment, external moment. So sum of all moment about point J is equal to 0 and taking the counterclockwise moment as positive. Okay, so you can see at point J there is external moment M which is counterclockwise, so it will be positive. The second moment is due to this 6x force, so 6x into perpendicular distance is x by 2 because this distance is x by 2. And this is producing counterclockwise movement, so it will be positive. The third force which is producing movement is 9 kilonewton, so 9 into perpendicular distance is x and it is producing clockwise, so it will be minus 0. Their sum must be equal to 0. So from here you will get movement is equal to 9x minus 3x square. If you simplify it, and the unit will be into kilonewton into meter. Let this is equation number 2. Now equation number 1 and 2 are the equation of shear force and bending moment for length of the beam. Range is given x is greater than or equal to 0 and less or equal to 4 meter. So it's valid for this region. Now we will move toward the x is greater than, I will write it, x is greater than x is, let I choose this color, x is greater than 4 meter and less or equal to 6 meter. It means that you have to cut the beam over here. So whenever you cut the beam, I will draw the free body diagram. So this is the length. Clear. Now this total length is x. Clear. So this distance, this remaining distance will be equal to 6 minus x. So this is length which is 6 minus x. Clear. And whenever you cut, there will be a shear force V and there is a moment, reaction moment M. And the load which is distributed load in this section, this is 6 into length of this portion is 6 minus x. So, and it will acting at the middle. So whenever this act at the middle, so this distance will be equal to 6 minus x divided by 2. Now we will apply the moment, we will apply the equilibrium condition. Sum of all force along y direction is equal to 0 and taking upward is positive. So two force, one is V which is upward minus 6 into 6 minus x. Their sum must be equal to 0. So from here you will get V is equal to 6 into 6 minus x and this will be in kilonewton. Let this is equation number 3. Now for moment we will take the sum of all moment about this point O. Let this is O. So O is equal to 0 and so external moment M, which is, you can see this is a clockwise, that is minus, and due to this force 6 into 6 minus x, and perpendicular distance is 6 minus x divided by 2. It is producing it is also producing clockwise, so it will be also minus. Their sum must be equal to 0. So from here you will get the moment equation. If you simplify it, it will be equal to minus 3 into 6 minus x whole square, and the unit will be into kilonewton into meter. Let this is equation number 4. Now equation number 3 and 4 is valid for x is greater than x, where I have written x is greater than 4 and less or equal to 6 meter. Now we have all the equation. We can draw the shear force and bending moment diagram. For that I have to draw vertical line. Let this is the vertical line, clear, and the length of the beam is 6. So let's say this is 1, 2, 3, 4, 5, and this is 6. So if I draw the line from this point till bottom, this here we will draw our shear force diagram. So V in the unit will be in kilonewton. Okay, so this is your 1 meter, this is 2 meter, this is 3 meter, this is 4 meter, this is 5, and this is 6. And one division vertically is taken as one division, we can check, one division is equal to, let's say it is 2 kilonewton. Okay, so first we will draw the shear force diagram. So you can see for x, this is 4 meter, this is 5, this is 6, 1, 2, 3. Okay, now we have equation number 1, and equation number 1 is this one. You can see, so when x is equal to 0, you can put in equation 1, so we will get v is equal to 9. Clear? For x is equal to 1.5 meter, you can take 1 meter as well, 2, 3, and 4. As much as you can put the point, you will get the points on this graph, and it will be easy for you to get a smooth line or curve. So I am putting x is equal to 1.5 in this equation number 1. So when you put it, you will get v is equal to 0. You can check 6 into 1.5 is 9. So 9 minus 0 is 9 minus 9 is 0. Now for x is equal to 4 meter. When you put it in equation number 1, so you will get v is equal to minus 15. Clear? So this shear force equation is valid for x is greater than or equal to 0 and less or equal to 4. For that we will apply, now we will use x is greater than 4 at, also again at x is equal to 4, you can put it in this equation, so you will get v is equal to 12. So at 4, shear force change from minus 15 to 12. Why? Because you can see at this point at x is equal to 4, you have upper load is distributed load, and below that you have at x is equal to 4, at this point there is a reaction force. So shear force changes from minus 15 to 12. Now at x is equal to 6 meter, you can put x is equal to 6 meter in equation number 3. Clear? This is 3. So 6 minus 6 is 0. So v is equal to 0. Now we have all the values, all the range. So you can plot them at x is equal to 0, v is equal to 9. So v is equal to 9. So let 1, 2, 4, 6, 8, 9 is somewhere here. So this is your first point. At x is equal to 1.5, we have v is equal to 0. So this will be at x is equal to 1.5. So this is your second point. This is x 1.5, and here shear force is 0. And at x is equal to 4 meter, at this point we have v is equal to minus 15. So 2, 4, 6, 8, 10, 12, 14, 15. So 15 will be here. Your third point will be here. And again at x is equal to 4 meter, you can see the shear force is 12. So we will go 2, 6, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 12. So this will be 12. And at x is equal to 6, we have b is equal to 0. So b will be this one. Now if I join these lines, so let me join this. This will be your this line, and then shear force changes from minus 15 to 12. And again from this it will goes to 0. So this is 12 kilonewton. This is 9 kilonewton. This is minus 15 kilonewton. And this is 0. So this is your shear force diagram. Now we'll move toward bending moment diagram. And again, what you have to do is you have to take a horizontal line. There, the length is shown over here, and here we will take the moment in kilonewton into meter. Along x-axis, it is x. Now for x is equal to 0, for x is equal to 0, I will write it. For x is equal to 0, we have moment when you put it in equation number 2, so you will get moment is equal to 0 kilonewton. You can check 9 into 0, x 0 is 0, minus 3 into 0. For x is equal, so it will be this point. Let first write this thing. Now at x is equal to 1.5, when you put x is equal to 1.5 into equation number 2, you will get the moment is equal to 6.75. Similarly, at x is equal to 4, you can put x is equal to 4 in equation number 2, you will get moment is equal to minus 12 kilonewton into meter. Okay, for x is equal to 6, we can have, when you put x is equal to 6 in equation number 4, you will get moment is equal to 0. Now we will plot all these points. So first we will plot at x is equal to 0, moment is equal to 0. So you will have this point. Clear? At x is equal to 1.5, we have moment 6.75. And again, let one division is equal to 2 kilonewton into meter. So this is 2, this is 4, this is 6. So 6.75 will be somewhere here. So at x is equal to, this is 1, this is 1.5. So at x is equal to 1.5, this will be your second point. This is 6.75 kilonewton into meter. At x is equal to 4, 4 means this point is 4. We have minus 12. So 1, 2, 3, 4, 5, 6. So it will be, your third point will be this. And at x is equal to 6, we have this is 0. Now you can check that this line is a straight line with the slope decreasing. So your bending moment will be a curve, second degree curve, and the slope will be in clockwise. So you have to draw it like this. Clear? Again, from this point till this point, from x is equal to 1.5 till x is equal to 4, you can see this shear force line is again a straight line with a slope decreasing. And again, the bending moment between these 2 points will be also a second degree curve, and the slope will be decreasing clockwise. So this will be like, I have to draw it like roughly. Better you can use the equation of m in order to get multiple points, and you can get the curve, smooth curve. Okay, so now from x is, this is 4 meter from x, and this is 6 meter. So you can see the shear force between 4 and 6 is again a straight line with a decreasing slope. So this bending moment will be again a second degree curve with a clockwise rotation. So this is minus 12 kilonewton into meter, this is 6 meter, this is 0, and this is again 0. So this is your shear bending moment diagram. So I hope you have now a clear understanding. I will repeat. First we have taken x is greater or equal to 0 and less or equal to 4, and we get equation 1 and 2 for shear force and bending moment. Then we take the second section, which is x is greater than equal to 4 and less or equal to 6 meter, and we get the shear force equation in equation number 3 and bending moment equation in equation number 4. Then we plot the shear force and bending moment by putting various values of x, and we get the shear force and bending moment, and then we plot them separately in shear force diagram and then in bending moment diagram. I hope you have enjoyed, and if you are new to my YouTube channel, do subscribe me and click the bell icon. Thank you for watching.